Practice exam 3, part 8. So this is the model universe question, the last question on the exam. Remember that a argument in quantifier logic is only valid if it has no counterexamples in any domain, right? So that means for the model universe method is just the number, the only thing that matters is the number of individuals in that universe. So as I've said before, you will not be asked about the natural interpretation, you'll not be asked to use the natural interpretation method to prove an argument invalid, but you will be asked to use the model universe method to prove an argument invalid, as this question gives you. It gives you this argument in quantifier logic, one premise, one conclusion, and it says, use the model universe method to show that this argument is invalid. So what you have to do is pick a domain, right? And I highly recommend just starting with a domain of two individuals. This means you write domain equals A and B, right? Domain A, comma B. A and B, those are individual constants. That's the name of the two individuals in your domain, right? Second, after you've picked the domain, rewrite these quantifier formulas stating what they mean in this domain, right? Where existential statements translate into disjunctions and universal statements translate into conjunctions, right? Because what does it mean to say, for example, something is f, right? There exists an x, fx. In a domain of two individuals, it means either A is f or B is f, right? Disjunction, fa or fb. Notice how we've changed form, moving from the quantified statement to the interpretation of that quantified statement in the domain of two individuals. It's gone from a quantified statement to a disjunction, and that's what happens with all these translations in when you've specified the domain, and using the model universe method, you specify the meaning of the quantifier statements for those domains. You specify the meaning of all the quantifier statements in that domain, and you then have formulas which are truth functional, right? They are now of the form conjunctions or disjunctions or conditionals or whatever. And as truth functional, we can use the old short truth table method, if you recall that, to show the argument invalid. That is, we can attempt to hone in on a counterexample by specifying the truth values of the parts, which will be things like FA, FB, or in this case, EA, EB, IA, IB, right? The predicate E true of the individual A and of B, the predicate I true of the individual A and a B. Those things are the basic building blocks, right? Those are singular statements and they're true or false. We try to find assignment of truth values to them which make the premise true and the conclusion false, right? And that, of course, is a counterexample. And if such an assignment is possible, if we can find that assignment of truth values, then we have shown that this domain does have a counterexample. And since, again, validity for quantifier logic means there are no counterexamples in any domain, right? If we find any counterexample in any domain, we've shown that the argument is in fact invalid. So if you find a counterexample with this domain of two individuals, we can therefore conclude that it is an invalid argument. Look, in this domain there is a counterexample. Here it is, EA equals true, EB equals false, whatever it is. That makes the premises true and the conclusion false in this domain. There's your counterexample. That's why the argument is invalid. If, when you're doing this problem, you cannot find an assignment of truth values to make the premises true and the conclusion false, you cannot therefore prove the argument is valid. You cannot therefore conclude that the argument is in fact valid, because it might have counterexamples in domains of more individuals. So what I recommend then is using a domain of three individuals, trying to find a counterexample in a domain of three individuals, Officially, it should be, if you can't find one there, you should have to go into 4 individuals and 5 individuals, but I'm just going to tell you, if you can't find one, if you can't find a counterexample in a domain of 2 or 3 individuals in the problem you're given in the exam, go back and try again. Okay? So, we've specified our domain. Next thing to do is to rewrite these formulas stating what they mean in this domain. Right? Translating the all existential statements to disjunctions and all universal statements to conjunctions. Right? Universal statement translates to a conjunction for obvious intuitive reasons to say that everything is f, that is for all x, fx, in a domain of 2 individuals means A is f and B is f. Right? So it's a conjunction fa and fb. All right. So the premise here is just there exists an x. Something is both I and not E, which means in this domain, it's going to be the existential statement becomes a disjunction, so it becomes either I, A, and not E, A, or I, B, and not E, B, right? Convince yourself that this is true, right? Something is I and not E. Something, okay? What are the two things? It's A and B. So either, disjunction, either A is I and not E, that's what this says, or B is I and not E. Okay, the conclusion here is a bit tricky. You've got a negated universal, right? Now, one way you can go about doing this is, and this should be, this is how I'll teach the general lesson here. What you have here is a truth functional form, right? Remember when we did these in the lectures, and as she explains in the text, when you've got a truth functional combination of quantifier statements, the truth functional form stays in place, right? So if you've got, say, a disjunction, I'll erase this, but if it's ex, fx, book, for all x, gx, if that was the formula, say that's the conclusion, when you're translating that into what that statement means in the domain of 2 individuals, the result will also be a conditional. Conditional remains in place. What does this say? If something is f, then everything is g. So what it would become is, what do you do when you're translating? You're translating the quantifier statements. Still doing that here, but it has a different result. What you'd have here is FA or FB, right, as the antecedent of the conditional. FA or FB, and then as the consequent, GA and GB in brackets. And that would be the way, that would be the interpretation of if something is F, then everything is G, which means if either A is F or B is F, then both A and B are G, right? That's what that means. So notice the form will stay in place. That rule, which you saw from the lectures and the text, that's also in play here, as in you could keep the form a negation, right? And you'd probably do a square brackets, right? And you'd make it to be not square brackets, and then you'd have a conjunction of EA hook IA and EB hook IB. I think I said that right. Right? And that would be your conjunction. So you'd have the negated conjunction. And then you'd go about assigning truth values. You want the conclusion to be false. That's the major operator, so that'll be false. So you'd want the conjunction to be true. And that's how you do that. But it's not the only way you can do it. You're entitled here. So just listen to that again if it sounded unclear. I think I got it all out. You can also just translate this into its equivalent formula. So let's do that. And we get, right, this is, I can CQN this, right? CQN, categorical quantified negation. What's this? This is an A form. All E's are I. Not all E's are I. Some E's are not I. Not A goes to O. Exist in X. E, x and not ix, right? Okay, so that's equivalent, and I'm going to translate this, all right? So what does this come out to? This comes out to, so the existential statement becomes a disjunction, so it's E, A, and not I, A, in brackets, or something is E and not I, so either A is E and not I, or B is E and not I. Okay? Now it's pretty straightforward. All you do is give me a list of, right, this is the premise, this is the conclusion. What do we want? We want the premise to be true, the conclusion to be false. Yep. Right? We just need to find an assignment of truth values to the parts. So in your answer, what you do is you give me a table. I'm just going to put it up here in the middle, which you shouldn't do on the page. Put it maybe on the bottom, just so you can see it. So here's my table. This is me looking for a counterexample, right? E, A, E, B, I, A, I, B. Those are my only elements, I think. And I'm looking for an assignment of truth values to these. That means making this true or false. It's true or false. This is the list of T's and F's. Those are the truth values, T and F. Trying to make premise true and conclusion false. If I can, I have a counterexample. Right, so let's make EA false, right? Because if I make EA false, right, I need to make this true. Condition for making a disjunction true, I just need to make one of the disjuncts true. If EA is false, then not EA is true. So EA, make that false. And if I make IA true, right, I've made this conjunction true, right? EA false, IA true. The conjunction is true. That suffices for this disjunction, that is the premise as a whole, to be true, right? Now, with that assignment, can I consistently make the conclusion false? Yeah, I can. I made EA false, so that makes that false, right? EA is false. This is a conjunction, so that's the falsity of this disjunct suffices, is sufficient for the falsity of the conjunction, so the falsity of this disjunct overall. I need this to be false, which means I need both of them to be false, right? Because just from application of the truth tables, remember this is just, remind yourself of the short truth table method if you, as I did when I taught this stuff in the lectures on this, I went back to the short truth table stuff. Remind yourself of them, but okay, so this is false. I need both disjuncts to be false, but I can do that, right? Let's just make EB false. EB false. It means EB is false over there, but that's still fine, right? EB false over there. This has already been made true by that being made true. EB is false. This can be true or false. You could write T or F here, and you just write, on this assignment of truth values in a domain of two individuals, the premise comes out true. Premises, if there's more than one premise. Here there's only one premise. On this assignment of truth values, the premise comes out true. The conclusion is false. This is a counterexample. The argument is invalid. Good luck.